Hey guys, welcome to Quadratic Equations and Functions. This is Chapter 9. This is where the algebra rubber really hits the road. You can use this to describe a lot of different things that happen in the world. You can use it in physics, you can use it in other sciences, not just for math anymore. For 9.1, we're going to begin with the function with the equation of y equals a times x squared. But first, do read through the opener, the early description by Galileo about what happens when an object falls is important to remember. It helps us to describe our equations. So 9.1 is wait, before I do that, there's a YouTube video. I put the link in there. I'm afraid it's not a hyperlink, so you'll have to type it in. But go to that. Before we continue, it's a video of to verify Galileo's statement that two objects dropped under the force of gravity will fall with the same acceleration regardless of weight. So take a look at it and let me know what you think, but then come on back. Hey, what did you think? Was that cool or what? Great, we're on 9.1, the function with the equation y equals ax squared. The graph of any quadratic function with the equation of y equals ax squared with a does not equal 0 is a parabola with a vertex at the origin. We have some vocabulary. You need to know what is a vocabulary. What does it mean to be reflection symmetric? What is the axis of symmetry? In this case in particular, of a parabola, and what is the vertex of a parabola? On to some examples. Okay, the activity is in your textbook. It is on page 527. It said use the window, and it gives you a window for your graphing calculator. Remember, it's the biconditional inequality that describes it. And graph all three of these equations on your calculator and sketch the graphs on a single grid on a separate sheet of paper. When you do the sketch, what I would like to see in your sketch is, the graphs. I'd like to see that. I'd like to know what the window looks like. So this information for the window information should be represented in your graph somewhere. Let's take a look at the, not that. This is what I want. Graphing calculator, we want to go ahead and enter our functions in. We need to go home. We're going to go to graph, menu, window settings. We've been told what to do, so we're going to go with a -20. -20. -20 and 20. Okay, so that's going to be our window for all of these functions. So our g of x was 3 times x squared our first graph. We want to go back to menu to put in another function. This says f2 in your assignment. It says g of x and h of x. Let's just use the f of x, and we'll use f sub 2 as our next one. So f of x, and this is, now remember when we take a negative in this case, this is like a -1 times x squared. You don't put the opposite of x in parentheses and then square it. So this is quite explicitly asking you to just put in a negative x squared, and we enter that, we get our graph. And finally we'll do our last one, which is f of 3, and that is a negative 3 times x squared. And we'll get that into our graphing calculator. And we've got it graphed. Okay, so I've got all three graphed in here. It said evaluate for f of 2, g of 2, and h of 2 to find out what the values are for that. Well, for f of 2, that's the f sub 1, that's 2 squared is 4, 3 times 4 is, what is it? It's 12, right? Okay. And then for g of 2, that's going to be a negative 4. And for h of x, which is our f sub 3, that's going to be a negative 12. So we'll have 12 for A, negative 4 for B, and negative 12 for C. So that's step 2. For step 3, it asks you, is negative 2, negative 12 on the a point on the graph of h of x, and explain how you know. We know that 2 is, but is a negative 2, negative 12 also on here. We can look at our graph, and this is for h of x, so this is our graph, the kind of black graph that I've got right here. And so negative 2 is on there. We know that parabolas are symmetric, and indeed we would find that is on the graph, and the graph is symmetric with respect to the y-axis, and therefore negative 2, negative 12 is indeed on a graph of h of x. Okay, before we go to step 4, I'd like to go back and let's just review these real quick. For the f of 1, we have our graph, and we can see that it opens upward. For the other two, where we have a negative coefficient, they both open downward. We see that one is wider than the other, and the red graph is our f of 2 graph, which is the negative 1 times x squared. You can see that that's wider than the f of 3 graph, and that's has to do with the coefficient. That's going to, the larger the coefficient, the narrower the graph is going to be, the more rapidly it will change for a change in the x component. Okay, now we're on to use a graphing calculator to make sketch of the following functions. Use the same window you used for step 1. Okay, so we can take a look here at these functions, and I guess my question for you before we even graph it is, what do you think is going to happen when we put these functions into the calculator? I'm waiting. What do you got? Okay, well, we're going to use f of 4 of x for our j of x, and that was 0.2 times x squared. Enter. There's our graph. Got to adjust the window, don't I? Get the windows the same, so window settings, that'll be a negative 20. Next one down is 20. Our y minimum is a negative 20, and our y max is 20. Alright, now we can compare the two graphs. We can click back and forth and have the same window. So our j of x is up first. We're going to enter in our next function. So k of x will be f sub 5 of x, and that's a negative 0.5 times, not y, times x squared, and we'll enter that graph. So what do you see for the points on the graph? We've got the one opens up, one opens down. They both have a vertex at 0, 0. The graph of 0.2 times x squared has a broader, it opens more broadly than the 0.5 times x squared. And if we look at 1.1, we can see that both of them open up more than any of the graphs from the first set of problems we did for the activity. So when you're asked to describe a graph, a parabola, you're going to describe where the vertex is, whether it opens up or opens down, and in some way, either quantitatively or qualitatively, how much it opens, how big of an opening does it have. For step 5, you're asked to evaluate J3 and K3. So for J3, we're going to put that into our calculator, I guess. It's x squared is 9, and 0.2 times 9 is equal to 1.8. So for J of 3, it equals 1.8, and for K of 3, this equals, let's see, that'll be a negative 5 times 9, right? And that's 45, negative 45. All right, and then for step 6, it asks, is a negative 3, 2.9 a point on the graph for j of x? Well, again, we know the answer, well, we know, because we know about parabolas, that they are symmetric, and that j of 3 symmetric about the y-axis, then j of 3 equals 1.8. Well, j of negative 3 must also equal 1.8. and not 2.9. So the answer to this would be no, and it has to do with the symmetry of the parabola. Step 7, here's the question. If a parabola is opening up, what must be true about the value of a in y equals ax squared? If a parabola is opening down, what must be true about a in y equals ax squared? We've just talked about it, so you should be able to describe the answer to that. Here we are with guided example 1. This begins on page 527 in your textbook and continues on through to the next page. And in this example, we're going to look at, without using technology, graphing a situation where it is a parabola. So here's our circumstances. Sketch a graph of the formula a equals pi r squared, where a is the area of a circle with a radius r. Make a scale on each axis. In doing this, ask yourself, what are the possible values of r? What are the possible values of a, area? So r will be the x-axis, a will be the y-axis, let's see, so we'll make this area, and over here will be r, which will be radius. I suppose I should make that a little r, huh? Okay, I'll do that. Now you'll notice that I've only got really a quadrant 1 graph here. And well, why is that? Why is it that only quadrant 1 is important? That's this, what are the possible values of r? What are the possible values of a? Well, what can the radius not be? The radius cannot be a negative number because we don't have a negative radius. We're not in a black hole or something. And also true is the radius can't be 0. If you had a radius of 0, you wouldn't have a circle. You'd have nothing. So is 0 a solution to a equals pi r squared? The answer is yes, it is. Let's make a quick t-table, just like we did for linear equations. This is r, this is a. And I know if r is 0, that a is 0. That is pretty easy. But that's not a solution. However, if I can get infinitely close to 0 but not there with a positive value, that is a solution, and so I have to begin there. I would put an open circle at 0 on my graph to indicate that that's where I'm beginning, but that is not a solution to the graph. Okay, so I make values for the table when r equals 1, 2, 3, and 4. 1, 2, 3, and 4. And estimate each to the nearest hundredth. This is done after you've done the calculation. That does not mean that you use 3.14 for pi. You use the pi button on your calculator. Once you get your results, then you round it or estimate to the nearest hundredth. So when r is 1, well, that's going to end up being 1 times pi, and that will be 3.14. For our second calculation, where r is 2, well, that's 4 times 3, or 4 times pi, right? 4 times, and that's going to give me 12.5, 0.57. Now I just want to check real quick. I use the pi button on my calculator. I want to use 3.14 just real quick. 4 times 3.14 equals, we get 12.56 if I use 3.14. So I get a discernible difference in results by using an approximation for pi in my calculation. It's small, but it's a different result. So we want to remember to use the pi button. For number 3, we get 28.27. And for 4, 50.27. Now I'd like to go ahead and do a graph of these. So make a table and then graph the points from the table. Remember, 0 is not a possible value. I'm going up to 50, so I probably want a y or an a scale that is different from the r scale. In the r scale, I think I'm going to go with, this will be 1, 2, 3, 4. I'll give myself a little bit of room. And at 1, I'm at 3.14. I need to get to 50, so let's see, if this was 10, 20, 30, no, I'm not going to make it that way. So I think I'll go with 10, 20, 30, 40, 50. 1, I'm at 3.14, so here's 5, and that's going to be about in here. For 2, I'm at 12.57, so a little bit over 10. This is 15. That would be about 12 and a half midway in between, and I'm at 12.57, so we'll go with a dot there. For 3, I'm at 28.27. Here's 25. 28 is a little bit over half. I'll put a point there. And then for 4, I'm at 50.27. So 50, this would be 55.27, is a little bit below halfway. Okay, I've got some points put in. I can now it says put an open circle at 0, 0. We've talked about this. 0 is not in the domain of R, but anything greater than 0 is. So I include that, and I connect the other points. And here I want to get a curve in a kind of a parabolic way. And for the expression, this could continue forever. For our work, it stops. You can purchase curves. There are flexible rulers that can be used to make parabolas. There is a plastic ruler called a French curve that has all kinds of different curves on it that you can use to draw parabolas. So there are ways to smooth this out a little bit, but do the best you can. You may end up doing it freehand. And it gets us to step 5. Use your graph to estimate the radius of a circle whose area is 12 square units. So the area is 12 units, and that's not quite halfway, so that's a little bit below 2, but hard to tell from our graph. So if I was going to estimate that, I would estimate that my use your graph that would be about 2. About 2 units. That's it for guided example 1. Let's take a look at one last example, and I'll let you get on with the work here. In this example, it said the graph of f of x equals a negative 2 times x squared is shown below. Estimate x if f of x equals negative 8. Okay, well, it shows us how to do that. They have, at negative 8, there is a horizontal line drawn, and we're looking for the intercepts. Where does negative 8 cross the parabola for negative 2 times x squared? And it looks, we have 2 points where we cross the parabola, here and here, and one of them appears to be negative 2. The other one appears to be 2. So it would appear that our estimate of f of x equals a negative 2 times x squared is negative 2, 2, as approximated by looking at the graph. Okay, that's really it for 9-1. Best of luck with this. I hope you do well on the mastery quiz. Looking forward to getting on to 9-2. Thanks a lot.